So probably it's a good idea to to take it slow, and then you can ask question and trying to be interactive as much as possible. Okay, and if you have any questions or comments, then you can just ask right away. Don't wait until the end of the session. Just ask because we have a few we have fewer people joining in. Okay, so yesterday I talked about this, right? So this is not the only. I mean, these are not the only ways to import data into R. There are several packages out there. Even to import Excel, Microsoft Excel format, there are several ways, several packages that you can use. But what I have written here is I found it very consistent every time I wait a minute. Okay, let's continue. So what I find these functions is that they works consistently whenever I'm trying it. So that's why I'm recommending you to use it. But anyway, you can explore other packages, other functions to import data. So yesterday we tried Heaven package to import Stata dataset. Okay, and again, these are very important concepts. So I think that's why people feel that art is a little bit difficult to start learning. That's why I'm repeating a few concepts several times so that you became familiar with these concepts. So you won't be so much afraid to use it. So whenever we work in R, we have to deal with function. So there are three parts, okay? The function name, the round brackets. So make sure that whenever you open the bracket, you have to close the bracket. So if you forget the closing bracket, then it won't work. And then there are arguments between the brackets. Okay, so function name, brackets, and arguments. So that's how function works. And in arguments, there are functions that you need to give arguments, and there are functions that doesn't need arguments, but we won't talk in detail much. If you want to discuss, we can discuss at a later date, but right now let's just take slowly. So for mStat, the concept is the same. We have function name, we have brackets, and then we have the argument. So like I said, almost all functions in mStats start with data. So yesterday we have seen tabulate function, which is tab, and summarize function, which is summ. Okay, so there is a question, what is the difference between sum and sum? Okay, so I have written a post about it. So sum function is basically coming from base R package, and then when you can use the addition arithmetic operation, the addition. So you can sum numbers 1 plus 2 equal 3, something like that. So our summ sum function from mStat is a little bit different. We just it generates summary measures of numerical data. So there are several measures that it generates. Okay. So let's Okay, so let's change the screen to the folder. Okay, wait. Let's change to folder. Okay, so what I'm going to do is I'm going to change to, I will go to drive C, okay, drive C. And then, so you still remember that there is a folder called exercise underscore SWR and drive C. So we will open this folder and then we will copy this, okay? We will copy this and then we will paste this. Okay, so today is day 4, okay? So I think it is not the one. Okay, let me delete it first. I think I move it to, okay, this one. Okay, I will put this under exercise underscore SWR. And then I will name this, okay, I will name this day 4, okay? You also follow the same process. So essentially what you should do is, yesterday you have day 3 R script. So copy that and paste here and then change the name. Okay, how do we change the name? Right click and then there is a rename. Okay, I think these are basic computer stuff, and the principles are the same for Windows and Mac MacBook. So rename it to SWR underscore day 4. Okay, and then we will open this file. Open. Okay, now you should have your RStudio open. Okay, so is everybody on the same page? Okay, so the reason why do we double click on the file? The reason we are doing this is we are changing the directory. So as you can see that here behind the console, there is a directory, our current directory. Okay, basically this is where you put your R script. Okay, C, drive C, there is a folder exercise underscore SWR, and we put our R script under that folder. Okay, so when you go to the file window, it should appear the same. Okay, so there should be SWR day 4. Okay, so you can see that there is a arrow, a little bit curved arrow. So say say you are going, you are browsing somewhere, okay? You are browsing somewhere and somewhere, say your directory is somewhere. So what you can do is you can just click this arrow so that define this file directory where be your directory, this directory. So I will click this. Observe what happens in the file window. Okay, so I will click this this arrow key. So you see our directory is going back to our folder. Okay, so this is because we double click on R script and open RStudio. Okay, that's why we got this one. Otherwise, when you just open RStudio from window menu, you will just, I mean, the default folder goes to your document. Okay, so at this stage, it's a little bit tricky to talk to the beginner how you change directory in R. So I don't think that is important. That is very much important then, because we can change our directory by double clicking on R script. So that's why I didn't say anything about change in rate. Okay, is that a question? Okay, so I think no question. So let's run this. Whatever we have written yesterday. Okay, so I'm going to click run. So first we will clear our wall space. Okay, run, and then we will read the patient data set. So run a patient data set. Okay, now we have our data set. Now I'm going to load the mStat package because we will use functions from mStat. All right. So if you see this red message, it is just saying that the package mStat is attached. Okay, so it means that it is working perfectly. Okay, so as soon as we load our data set, what we should do is we should check our data set. Okay, so we will run this command. So you can see I'm going to increase the font size. As you can see that you can change, you can change this width by dragging this this symbol. Okay, you can change the width by dragging here, so that it will appear nicely. So like I said, we have 25 variables, and we can check there is no missing values. Okay, and we will look at each variable in a moment. So next, what we should check is whether these type are logical based on a variable. Okay, so I think we don't have a metadata, which is like instruction to indicate which variables are which, but we can guess. Okay, so there is a hospital data set. Okay, coming from a hospital, and these contain 120 patients. Okay, so if you look at if you go to the environment and click this, so we should have, you will see this kind of spreadsheet. We can zoom in using, by clicking here. Okay, I'm going to zoom in, zoom source. So what I'm going to do is I'm going to go through a little bit. Hospital, we have a variable called hospital. So you can see that if you drag down, you see that the value change. So there are two values. Okay, one is UCLA, and the second one is UCSF. Okay, so we have two value and a hospital. So when we consider about data type, this should be nominal data type. Okay, it is categorical. Okay, let's consider whether this should be categorical or numerical. Next, we have hospital ID. Okay, and what we can do is we can click here to sort, alphabetically or from lowest to highest. So when you click once, you see the symbol change. Okay, it means that it is sorting alphabetically. And when you click again, it is sorting alphabetically from the last one, or highest to lowest. Okay, so you see that there are two hospital, hospital ID 1 and 2. Okay, And then next, so again, when we think about it, this can be a number or a categorical, but this number may represent a category, okay? So next is DOC ID, which is a doctor ID. So as you can see that when you see something like hyphen, this will be string characters, okay? And these are the ID. So everyone should have, so every doctor should have a unique ID, okay? So you know, we have something like one doctor may have 7 patients, okay? So that's why we see that row number 1 to row number 7 have the same doctor. So every doctor has a unique ID. And next is DIS_DATE, which is a discharge date, okay? So which is a date format, okay? So it is neither categorical or numerical. We will talk about how to deal with dates later, okay? And next we have a tumor size. As you can see that this has decimal point, you see? So, okay, let's make this interactive, okay? So when we see decimal point, what kind of numerical data it is? Can somebody answer?
Continuous.
Yes, continuous. Okay, next CO2 level, it is, it contains decimal points. So what kind of data type it is?
Continuous.
Continuous, correct. And next we have pain, okay? So let's click, let's see. So we got 9 in the last row, the biggest one, and 1, okay, the lowest one. So 1, 2, 3, 4, 5, 6, 7. What do you think it is?
Will be ordinal.
Okay, one answer is ordinal. Another answer can be? What do you think? There is, we can call this another one. What do you think it is?
Range.
Okay, so discrete variable. Okay, this can be discrete variable. This is the, so the problem with this is we don't know how they measure pain, okay? So whether it is like you said, ordinal, like lowest to highest, or whether it is some indication, or whether it is the number of days you feel pain, okay? So we don't know what it is. So we can treat either as ordinal variable, or we can treat as a continuous discrete variable. So that's why we have to explore it, and we have to understand our data. And the same here, 1, okay, the lowest 2, and the highest 9, okay? And next is mobility, the same here, okay, 2, 9. Anti-tumor, so this is the number of tumor and tumor. So 0, we got a lot of 0, and we got 9, okay? And morphines, we got a lot of 0 too, and we got 13 as the highest. So this is exploring your data, okay? So even you don't, when you import your data into R, you don't even need to like tabulate or summarize. You just, you know, open the data set and try to see, I mean, look at a glance at your data. And in a moment, you will see you will appreciate this. Okay, let's see, remission. Okay, so whether you someone has cancer remission or not. Okay, 0 could be no, and 1 could be yes. So this is obviously nominal data, okay? Next, we have lung capacity. So obviously decimal point, so continuous, decimal point, continuous. So as you can see that, let's click this. So can you see this strange value? So land capacity, every other values. Okay. I think we have the same problem as yesterday. Updating problems. Okay. Okay. Anyway, if the meeting stopped, just rejoin it. Okay. Anyway, so you can see that the other values are 0 point something, and here is minus 90, 98 or minus 99. Okay. We call this data coding error. Okay. So we need to change this in our data set. Okay, that's why we have to explore it. Otherwise, when you summarize it, as yesterday, when we find a means, this is negative 98. So it will pull the mean from its real location. Okay. So that's why these values are very important to check. And as you can see, H, we got decimal point. So, and click to see the highest and lowest. As you can see that H can never be more than 100, okay? It's rarely to have somebody with 100, more than 100. So you should always check the value, lowest and highest, okay? And next, the merit, okay? And merit is yes and no, okay? 0, 1, yes and no. Okay, family, same here, right? Minus 99, minus 99. It should be category, yes or no, something like that, okay? Yes or no. But there is minus 99. So obviously this is data coding error. Smoking is the same, okay? Smoking is the same. Okay, so I think you got the idea, okay? So you as soon as you load the data set, you open this spreadsheet like the view, spreadsheet like view, and then you check minimum and maximum, okay? Whether the value coded here or coded, I mean, we don't know it is correct or not, but we can sense that it is way out of, our normal value. So we should check. That's the idea, okay? So we also have this minus 99, test 1 and test 2, okay? The same. So when you have your data set in your hand, it is very important to check. It is very important to explore before you do any inferential statistics. So that's why descriptive statistics is really important. Okay, now let's change it back to the normal view. Yes, Tinley.
When you have spread the data, do we have a way to toggle the key and then see the code there in the spreadsheet?
Pardon, can you repeat the question again?
When we have spread the data, is there a way to toggle and then see whether it's showing only the values? Can we see the labels also, the codes? I mean codes.
No way. There is no way. Okay, so I think you are talking from your experience of using Stata, right? So when we open spreadsheet like program, what you mean is okay, wait. Okay. You mean that the label, right? The value label.
Yes.
So here it's not like Stata. So we don't really put the value to the label to the value. So in R, there is the weight of R. Okay, so when you either you code as numeric or you code as character, there is no way to label the values, and it is not necessary. And we were talking. I mean, you will see it along the way of our analysis. There is no need to look at the label. So no, there is no way to toggle the values and the label. So like somebody said, what you see is what you get. Okay, so you see number, you get your number. That's it. Does it answer your question?
Yes.
Okay, so we will go back to here. Okay, so here, as soon as you load the data set, it's very important to check the data set. Okay, that's why codebook is important. So you can see that there are some label missing. Okay, so here is an A. Okay, let's talk about something. We will just go down. Okay, so what we will do is we will just give it date 4. Okay, and what I'm going to talk about is an A. Okay, okay, an A, all capital. Okay, and A. Just basically means not available. Which is missing value in R. Okay, because we will deal with missing value a lot in R. As you can see that there is minus 99. Okay, this is definitely data coding error, and we don't know the reason why they code minus 99. But right now we assume that these minus 99 values are missing values. Okay, so we will recode them as it is. But first we are going to look at the what we have discussed so far in previous day. Okay, again we will summarize. Okay, we will summarize single variable, single numerical variable. Okay, what is the function? Summ sum. Okay, summ sum. Okay, so like I said, mStats function have you put your data set in as the first argument. So we put our data set. Our data set is patient, and then we will check age. Okay, age, and then we run this. Okay, how do we run this? We can run either by running this button. Okay, or the next note for today is shortcut key for today is to run line by line comment. Okay, this is line by line. Is control enter. Okay, I think for MacBook, Mac user, you should press command key plus enter. Okay. So I'm going to put my cursor here and I'm going to press Control Enter. So this appear the same. Okay. So as you can see that we got age variable, and then we got 120 observation, no missing value. But look at this. Okay. We got maximum value of 357.9. Obviously, this is data entry error. Okay, so why don't we restart the meeting, and meanwhile you're trying to look at the value of WBC, RBC, BMI test 1 and test 2, okay? And then we will discuss more. Okay, so is everybody here? Okay, let's wait a few more. Okay, so can you try to run this? So one thing you will notice is when you drag here, I mean, when the space for this console is narrow, it's a little bit cranky, right? It's a little bit, crowded. So always make sure to give enough space for it appear to be, nice and stylish. Okay. So is everybody, has everybody written this and ran this? What do you think will appear? What happens when we run this? Somebody answer. What will happen if? Can you answer?
It's not working. It's not working.
And what does it say?
There's error in 1 minus h, something non-numeric argument to binary operator.
Yes, exactly, right? So argument is not numeric or logical. So basically this one, if we look at the codebook again, you can see that it is character, right? Okay, everybody know character, right? It is not numeric to say. These are string numbers, okay? So when we import this using read underscore DTA, the raw data set is coded as a character, as a string, which is not correct. WBC is numerical value, so we should change this to numeric. Okay. Okay. So altogether, which variable have the problems? Obviously, WBC has problem because you can't even run it. Okay. What about age? What problem we have in age?
The maximum value?
Yes. Okay. So our problem so far in this data set, okay, we have so many problems in our life. So for this data set, we have age maximum value is invalid. Okay. Second problem. Second problem in this second line. What do you think? Okay, first, we don't know what is test 1 and test 2, okay? You don't know test 1 and test 2. Test 1 is interleukin 6 value. Test 2 is CRP, C-reactive protein. So here, clinician, I think we have some clinician, okay? So I'm not sure, you should make comment about the value, whether it is valid or not, okay? So test 1 is interleukin 6 value, and test 2 is CRP value. And BMI is body mass index, and RBC is red blood cell count, okay? Okay, so if we look at red blood cell count, do you think it is okay? Look at mean, standard deviation, median, quartile 1 and quartile 3. What do you think it is? It is okay or not? Values make sense or not?
RBC is okay.
Okay. Yeah, I agree. We can discuss more if you don't agree, because I think I'm not used to reading the full blood count. So, but at least I think it is okay. Let's look at the BMI. What do you think of BMI 57? Is it plausible? Is it a plausible value?
No.
Okay, so we will check this, okay? But let's consider. So what would be the maximum BMI value? What should be the maximum BMI value? Valid one. I think this should be okay. What do you think? 58.
It depends upon the patient, no?
Yeah, obviously. Right? Okay, if you consider every possibility, do you think 58 is okay or not?
It's okay, I think.
I think it's possible, but I haven't seen a 58 BMI patient so far.
Okay. I think we will check the data set. Okay. Let's open the data. I mean, this is the fun of looking at your data. So let's go down to BMI. Okay, so we only have 2 patients above 50. Okay. I don't know. I think maybe this one is some data entry error or something. But still, I think this is plausible. So we won't change anything to BMI. Okay, let's agree on this. But when you are working with your, actual data set, this is for demonstration. So when you are working with your data set, you should really have an idea like that. Okay, for test 1, interleukin 6, IL-6. Okay, -2. I don't know. What do you think? -2. There should be -2 or not?
No. I think that
I
is.
think no.
Yeah, so I think there are 2 extremes, right? -2 and -99. So I think these should not be. And let's look at again our test 1, interleukin 6, and yeah, so where is -2? You can see that these are means, right? So there is no actual -2 because there are a lot of -99. It pulls the mean. It pulls the mean beyond 0. So that's why the mean is -2. So you can see that, right? When you have extreme value, your mean is not a very good, very reliable statistics for your sample. So that's why we need to check the data. Okay, so we are now sure that our problem, test 1 and test 2, -99, where we recorded as missing value. Okay, what do we call missing value in R? Someone? Can you answer?
NA.
Yes, NA, all capital, okay? NA. Okay, so that's one, there's 2 values of -99 where we recorded as missing value. Okay, so that's it. I think right now we have 2 problems. Age maximum value is invalid. So we are going to change this, okay? We are going to replace it, replace the value of age, okay? How do we replace it? So this is all in the book, in the guidebook to mStats, okay? So how do we replace the value of age? There is a function in mStats called replace, okay? So what you do is you replace, type the replace, so that is the function name, okay? All functions in mStats start with data set, so you put your data set, patient, okay? So what will you replace? Which variable you replace? Age, okay? And what is the value you want to replace? Okay, we'll put NA. Okay, what is the value you want to put? So what is your data set? What is your variable? And what is the value that you want to put? Okay, NA. So what is the condition? Next is what is the condition that you want to put? So if age is more than 100, do you agree? If age is more than 100, okay, we will replace the value of age to NA if age greater than 100. Okay, so the condition, here is the condition, is age greater than 100. Okay, so we got our function name replace, and the first argument is data set. We put our data set. Second argument is which variable are we going to replace? Age. Okay, what value we will replace? NA. What is the condition we want to on which we want to replace? So if age more than 100. Okay, so we will run this. When you run this, okay, let's look at this output one by one. Okay. Okay, forgot this line. Okay, and look at this line. One observation replaced with NA. This is really important. Okay, because if we look at here, how many row we see with 357.9? Only one row. Okay, only one observation. So that's why when we change it, when we replace it, this should replace only one observation. Okay, so this is correct. Okay, only one observation is replaced with NA value. But we have this output. Okay, which basically means that nothing happened in our data set. This one. Okay, let's look at here. Open this and let's look at the age. It is still there, right? So when we run this, we just run the function name and then see the output. We haven't put what we have into the patient data set. So we have to put what we got here into patient data set. Okay, what it is called? It is called assignment. Okay, it is called assigning whatever we have into object. So everything here is object. Okay, well, assigning our output to patient data set. Okay, so how do we assign this? So we will copy this, copy paste this. Okay, and then okay, when we run this, we have this output. We want this output to put it, so we give a direction. Okay, the direction is less than and then hyphen without space. Okay, so basically mean, as you can see, this is like the arrowhead. Okay, direction. So this line tells us whatever we have here, we will put this where is it? Okay, wait. So basically whatever we have here, we will put this here. Okay, so we should give a name. We should give a name to this sentence. Okay, so let's try giving it patient 2. Okay, we don't want to overwrite the original data set we imported. So we give a new name and then we will consistently use the new one. Okay, so let's run this. So right now I'm going to run this line of command and then observe what happens in the R console. Okay, what is the difference between these two lines?
In one, the value is assigned.
Yes, this one, the value is assigned. So it does not, give an output anymore here. Okay, so output has been assigned to patient 2, and then you will notice that there is another line appearing. Okay, another data set called patient 2. So observation is the same, variable is the same. Okay, And next, what are we going to do? We will change minus 99 in test 1 and test 2 to NA. Okay. So how do we do this? The same. Okay. Replace. We gave data set, patient. What is the variable? Test 1. What is the value we will give? NA. What is the condition? So the condition is this variable is equal to, okay? So test 1, okay. Replace test 1 to NA if test 1 is equal to minus 99. Okay, so what is the condition? Test 1. If test 1 is equal to, that is a condition. Okay, so we will check the condition by using the symbol to equal. Okay, minus 99. So you will notice that I am putting space, okay, carefully after every comma and between these variable and the symbol, okay, so that we can read this easily. So we will replace in the data set patient, the variable is test 1. We will replace if the condition is test 1 equal to minus 99, and then we will give the value NA. And then whatever output we have, we will put it on the patient 2, okay, consistently. So you see the arrowhead is directed towards the new this object. Okay, so I will give you 5 minutes and then trying this is example, and then why don't you try test 2 by yourself, okay? Replace test 2, the same, right? Test 1 and test 2 the same. Is equal to minus 99, okay? Okay, so I will give you 5 minutes. Why don't you try it? And if you are finished, just let me know you are finished, okay? I think right now, what I'm trying to do is we explore our data set and try to fix our data set while we are exploring it. Okay, so this is called data management. Okay, so data exploration or descriptive statistics, whatever you call it, and data management should come hands in hand. Okay, at the same time. So you explore it. When you see something weird or awkward, you check your value, then fix it. Yes?
7 observations replaced.
Pardon?
For the test 1 and test 2, both 7 observations have been replaced with NA.
For test 1 or test 2?
For both the cases.
Okay. So I think I'm wrong. Oh, I haven't ran it yet. Yes, correct. So we should also check, right? Let's check this. Okay, 2, 6, 4, 6, 7. Okay, 7 observation. So it should be consistent. Okay, sometimes you don't have to type everything, you just copy paste. Okay? Okay, so let's check patient 2. Okay, should be fixed. Sorry, it's not fixed. Okay, because the reason is we should use consistently the data set. Okay, so the reason is we change age and then we put it patient 2. So what about we want to change it? We want to use patient 2 data set from onwards. So we need to change these data set to patient 2. Okay, so can you do that? And then run everything again. Okay, so from start to finish, run everything again. Okay, so that is the function still not working. So we will just give a comment. Okay, how do we give a comment? We press Control Shift C. Okay, Control Shift C, Control Shift C. Okay, so has everybody finished? Okay, no response. I assume everybody has finished.
Yes, sir. Finished. Sir.
Okay, so right now what you can do in R is you can summarize and you can tabulate. And right now you have learned how to replace the value. Okay, if a certain condition is met. The next one. The next one is we want to change, okay? We want to replace our WBC, okay? Right now, WBC, if you look at our codebook, where's our codebook? In our codebook, WBC is still character, okay? So we need to change WBC, replace WBC with numerical values. Okay, we will use the function. Function is s dot numeric. Okay, the function we will use is s dot numeric. Okay, so we will replace it. So how do we write? What is the main function? The main function is replace. Okay, and we put our data set. Okay, like I said, we will use the newly created data set consistently. So we will replace our patient 2. And what is the variable? Variable is WBC. Okay. Previously we put NA, right? Right now, what do we put? We will put the numerical version of WBC. Okay. So s dot numeric WBC. Okay, so here there is no condition. Okay, we want to change everything of WBC to numeric. So basically this means that we will replace in a data set WBC, we will replace WBC value with the numerical version of WBC. Does it make sense? And we won't specify any condition. Okay. And then we will put this into patient 2. Okay, so let's try run this. Okay, what is it? So it just means that you see 120 observations replaced with this numerical version of WBC. Okay, but some value has been replaced with NA. Okay, we will see. So 120 value very 120 observation has been changed. So we will check our codebook, okay, of patient 2, the new data set. So if you check the patient 1, there hasn't changed. We haven't changed anything to patient 1. So there is The only thing change, the only change we made is in patient 2. So we will put patient 2 and we will run this. How do we run this? Pressing Control Enter. So you can now see that this WBC has become numeric. And with 2 value as NA. Can you see that now? And now, if we remember from our conversion, replacing H to NA and test 1 and test 2 to NA. Okay, for H we have 1 value, one observation with missing value. Okay, and then in test 1 we got 7 observation with missing value, and test 2 the same. Okay, so basically what it means that for each variable we got 0.8% missing value. So it's negligible, not much. And we got 5.8%, around 6% missing value. Okay, so let's demonstrate how invalid value or extreme value can distort our means. Okay, so first we summarize our patient data set. Okay, not patient 2, patient data set. We will summarize each okay, test 1 and test 2, and then we will compare with patient 2. Okay, age, test 1 and test 2. Okay, we will run this at the same time. Okay, so we will select both line and then run this. Okay, so the above one we use patient data set. The below one we use patient 2 data set. Okay, so as you can see that for age we got 53.6 and standard deviation 28. But when we remove the 357 something, our mean has come down to 51 and our standard deviation becomes narrow. You see, it is 29, it is 6. So at least 3.5 times lower, narrower. So which means that our age has become more precise. But if you look at the median and IQR, it's barely changed. Do you get it? It's 51 or 52. It's 47, 48, 55, 55. So it's barely changed. You see how robust the median and interquartile range is. And then let's see test 2. The same, right? So when we remove the negative minus 99, the mean becomes 4 from minus 2. And for test 2, the mean becomes 4.8. And standard deviation drastically changed. See, 24 to 3. So which is 6 times. Oh, not yet. 7, 8 times. And it is also 8 times difference between when you remove the invalid value and when you don't remove the invalid value. Okay, so that is why exploration of your data is important. Okay, so any questions?
No questions.
So far, what we have done is looking at the numerical data, okay? And yesterday we have looked at the tabulation, okay? So let's look at the tabulation again. And for this, right now, we will look at tabulation of, again, we need to refer to the codebook, okay? Tabulation of everything. We should look at every categorical variable, okay? So let's quickly go through which one could be categorical. As we said, pain, worn can be categorical, okay? But right now, let's move to this one, okay? Married, family HS, smoking HS, and sex to lung cancer. Okay, so tabulation of married to cancer stage. Okay, so we will use tab function, and remember the first argument is to put your data set. So right now we are using patient 2. Okay, let's use patient 2 consistently. We'll use patient data set for comparison. Patient 2. So this is the range, okay, from married to cancer stage. So we can use 2 dot colon separator. Married 2 dot or colon, and then cancer stage. Then we run this, okay? So this is one-way tabulation, not cross tabulation. Okay, so we got married. Okay, married one, so more than half are married. It's nice. And look at the family HS. We still got minus 99, right? For smoking HS, we still got minus 99. And for sex, we got 12.2. So these are invalid value or extreme value or something we should look at. Okay, so the first time, as soon as we import our data set, we checked our codebook. We already checked it, but we didn't see any missing value, right? Because based on the data collection method, some people, some researcher, they use minus 99 to indicate missing value, minus 9 or 9 or some value to indicate missing value. So that's why we didn't see any missing value, but we need to recode this as an A. Because if you just leave it as it is, then your summary, your tabulation will be wrong. Okay. Okay, so I will give you. Why don't you try yourself? Change this minus 99 for family HS and smoking HS. Change sex 12.2 value to NA. Okay. So homework for tomorrow. Change minus 99 of family HS, smoking HS to NA. Okay, that's a homework number 1. Number 2, change 12.2 of sex to NA. Okay. Okay, so any questions or any comments? Or any, discussion you want to make?
Will we be learning tomorrow about the cross tabulations?
Yes.
Great, thank you.
Yes.
Can I ask you one thing?
Yes.
Do we have any command to change like more than 3 or 4 variables at once? For example, we have a missing value like 99 for 3 or 4 variables, then can we change at once for them?
You want to recode multiple values?
Multiple variable at once,
or you mean variable at once?
Yes.
I think you can use recode function. Yeah, but okay, so I think I will talk about 5 more minutes. Okay, if you want to leave, that's fine, but just to demonstrate a new concept. Okay, do you remember we installed a library magrittr Do you remember?
Yes.
Okay, magrittr. Why do we install it? We want to use the pipe function. Okay, it is a little bit advanced, but don't worry. I will repeat this again and again so that you are familiar yourself. You are familiar with it. Okay, so this is called pipe function. Okay, the symbol is without space. You put percentage, 2%, in the middle you put greater than sign. Okay, what does it mean? It means that whatever in front of this pipe is being forwarded. Okay, like an email is forwarded, it's being forwarded to the next line, to the next function. Okay, I will demonstrate it. Okay, so we got patient 2. We have modified patient 2, so we won't use it. We'll use patient data. Okay, and then we want to so we provided patient data set, so and we forward it to the next line. Okay, so we will go to the next line, and then okay, we will do this from the start. First, you need to load the library. Okay. Okay, first you need to load the library, magrittr. And then, okay, let's start. We put patient data set and forward it to the next line. Okay. And then what will we change? We change age to age more than 100, then we will change it to NA. Okay, so we use replace function. So here is a little bit change because I already said that the first argument is data set, right? So if you use this, you don't need to specify data set. Okay, so you just go straight to the variable age. We put NA if age is greater than 100. Okay, and then whatever the output is, we will forward it to the next line. So this one is the data set. This data set is forwarded to the next line, and then we change it, and whatever changes forwarded to the next line. So you see it's a change auto, and then we replace it. Next is what? Test 1 NA if test 1 is equal to minus 99, and then we forward it, replace test 1 NA, sorry, this should be test 2 is equal to minus 99. So when you run this, okay, you got an output because we haven't assigned anything. Okay, we will assign this to okay, let's say patient 3. Okay, so you see we replace age with NA, so 1 observation change. Test 1 and test 2, 7 observation. Okay, so so we have the same output like we have written line by line. Okay, so this is more compact, and in my opinion, it is more easy to understand. It is more easy to read. Okay, like first we put patient, and then replace age, and then replace test, and replace test, and then see the output. Okay, so let's look at the summarization of patient 3, age, and test 1 and test 2. The output should be the same, right? So there shouldn't be any more extreme value or invalid value. So it should be any values in each category. Okay. Right now, I would just tell you one more thing is how to find help. Okay. So say we want to look at how we can use sum, SUM as sum function. What you can do is you can give a question mark and then type sum. Okay. So you will see something like this. You can see there is a yellow box with a question mark symbol. With a question mark. So you click it, then you run it. Okay, you run it. So you will see that in this help tab of find window, you will see the documentation which I have already written. Okay, so how to use sum generate summary statistics for numerical data, as well as group summary measure, which someone said cross tabulation. Because right now we are looking at single variable, okay? We're not looking at the relationship between two variables, not yet. So tomorrow we will look at relationship between two variables. So right now we use we look at summary statistics for numerical data. So how to use it, and what is the output, and what is the output mean annotation. Okay, what is OBS mean? It is observation, something like that. I've already give some documentation so you can read it, and I also put some example which is not very elaborate, but anyway you can read the guidebook. It is everything is there. Okay, I put as much detail as I can to the book. So I think at least you should read the book of mStats. So let me just open quickly to the book. So this is the mStats guidebook, which can be used with this current version, 3.2.1 or 3.2.2. And I'm going. Okay, so the first chapter is a little bit introduction to mStats and why the need and everything. And basically this webinar follows this book, so I think you should have a look. And how to install mStats. So those who haven't figured out how to install it, you can discuss with me, or you can reference to the book. And today we talk about replace. Okay, here is the replace. And so you can look at the replace. Okay, I think you can click it if you change to, and it is click it, and then you can read how to use replace function. Okay, you can reference to the book, but right now let's so we replace 3 variables today: age, test1, and test2. What do we call this process? We call this data management. Okay, so I put under data management category. So the chapter 3 talks about data management, which basically you already learn how to check the data set, and you learn how to replace it. Okay, and in next few weeks you will learn everything under this chapter. And then at the same time we are talking about descriptive statistics. Okay, so right now you have already learned how to do a summary and measures for one single numerical variable and one-way tabulation. So tomorrow we will talk about cross tabulation, group summary measures, a little bit about some of these functions. So these are not meant to be learned in one day. Okay, if you can learn in one day, it's fine. You can obviously do that. But I don't want to discourage you, so just take it slow. just take step by step, and then at the end of this month, we all can, easily do data analysis using this mStat package inside R. Okay, so in due time, we'll talk about linear model and logistic model and how to tabulate their regression estimate. And then we will, in due time, we will talk epidemiological calculation like odds, risks, rates, and how do we calculate the attributable risks, risk difference, population attributable risks, efficacy using this package, okay? And also this is very common methods in epidemiological calculation, Manta-Hanza method, okay? Also, you should, as a researcher, as a medical researcher, you should know these methods. Even if you don't know in details, you should interpret the results, and you should know how to do that in our software. Okay, essentially, at the end of this month, you will learn everything from this book. So only 1 month. And even now we already on days 4, so 3 plus 3 weeks to go on. Okay, so any questions? Anything you would like to add, or anything you would like to request, or anything? Okay, I think so. No questions. I think we will stop. We will stop here and see you tomorrow. Okay. So you got homework. Okay. Yes.
Thank you so much, sir. Thank you.
So you got homework. Okay. I'm going to. I will share this this file on the Facebook group. Okay. So just look at it and then try to do that. Okay. This homework for tomorrow. Okay, so see you tomorrow, everyone.
Yes, sir.